Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
So in order to use molecular orbital theory to predict if these molecules or ions exist in stable forms, we're going to first need a sort of orbital thing that we can work with. So since we start at the bottom with a sigma and a sigma star, these are going to indicate the s orbitals. And that's good enough for A, but for B and D, we're going to need the pi orbitals. So I'm going to go ahead and put those in. It's going to start with another sigma into 2 pi's, and then 2 anti-bonding pi's, and an anti-bonding sigma. So this is a molecular orbital diagram we're going to use. For H2, 2 minus, we get 1 electron from each hydrogen, and then 2 electrons from this minus 2. So we fill 1, 2, and then 3, 4. And we see that we have the same number of bonding electrons as anti-bonding electrons, which means our bond order for this molecule is going to be 0. So we do not expect this to be stable. I'm going to skip B for right now, because C has a very similar setup to this. It's got helium-2, 2 plus. So helium-2 is 4 electrons. 2 plus means we're only looking at 2 of them. So we're just going to have this bottom section here. That forms 1 bond because it's got 2 bonding electrons. So yes, we expect that to be stable. For neon-2, we can take a quick sort of educated guess. We know that neon is a noble gas, which means it really doesn't like to bond with things. And we're going to just kind of show that here. So neon has 8 electrons around it, which means 2 of them have 16. I've already got 2 in my diagram. I can add 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've completely filled up my diagram, which is good because we're out of electrons. And we see that for every bonding electron, there's an anti-bonding counterpart. For these 2, there's 2 here. For these 6, there's 6 here. Which means that there's not going to be any electrons, any sort of net electrons left over the bond. So this is also not going to be a stable molecule. And it turns out that F2, 2 minus is actually in a very similar state. So fluorine has 7 electrons around it. 2 of them gives us 14. And then the other 2 from the 2 minus is 16. So that's just this picture here again. It's isoelectronic. It has the same number of electrons, so they fill the orbitals the same way. So we're also not going to expect this to bond.